Friends, we are going to take up a difficult topic, uh, the errors that you make in calculating gene frequencies. You know you have Hardy-Weinberg principle. The issue is not at present Hardy-Weinberg principle. The issue is Hardy-Weinberg equation and how it helps in the calculation of gene frequencies. The first thing to begin with, you have the concept of gene frequency. Now, right from genetics started, this term has been there. The fact is, there is nothing called as gene frequency. The frequency of a gene in a population is always equal to unity, is always equal to 1. So what we have is not gene frequencies, but allele frequencies. If there are n number of alleles of a gene, the sum total of all the allele frequencies is the gene frequency, and that is always equal to unity. That means if we have two alleles and their frequencies are p is to q, then p plus q is equal to 1. If there are three alleles, then p plus q plus r is equal to 1. If there are four alleles, then p plus q plus r plus s is equal to 1. The sum total of all the allele frequency of a gene is the gene frequency, and that is always equal to 1. That you must realize. And why this issue we are discussing? Because in the most of the books, Indian books, it's not given properly, or it is erroneous. A little bit is given by B.M. Das, but that is not easy to understand. I once read in a book on agricultural genetics in Pusa, there it was given. I read it in Cavalli Sforza and Bodmer, and regarding three alleles, I straight away took from Kurt Strand, Principles of Human Genetics. But we will be discussing presently only two alleles. Even they are not given properly. What is written in the books? It is, if they are, then p plus q is whole square is equal to p square plus 2pq plus q square. Then if next generation again keep squaring, that doesn't serve the purpose. That does not help you understand it. In one generation they square it, in the next generation they further square it, next generation they further square it, they keep squaring. That doesn't serve any purpose. Then in one generation you will have allele frequencies this, genotype frequencies will be this. In the next generation genotype frequencies will be this. Every time they keep squaring. That doesn't serve and that doesn't help you understand. The simple way to understand is that if there are two alleles of a gene and they are in the proportion of p is to q, then the genotype frequencies are represented as the proportion of the square of the sum of the allele frequencies. That means it is represented as p square is to 2pq is to q square. The genotype frequencies are represented as the proportion of the square of the sum of the allele frequencies. Now, what they do in the books? They straight away give, let us say, this is your 0.25, this is your 0.5, this is your 0.525, that makes it 1. Something like that. That is not the case. The rule is that when you are talking about, if we take the simple Mendelian example, say let us say you have tall and you have dwarf. In this, the frequency of tall is given by P and that of dwarf small t is given by Q. So in F1 you have F2 you have 1 is to 2 is to 1. That means this is your P square, this is your 2PQ and this is your Q square. Expanding this. What they give? They give the whole number and they split 50-50 on the two sides. That is not the right approach. How can we calculate actually? Simple way is that we take the percentile of all the figures which are there. Let us say we have with us 150 tall and 50 dwarf. That means sample size is 200. In that case, what is the percentile of the two? This is 0.75 and this is 0.25. You know, this is your P square plus 2PQ, capital T and capital T small t. You cannot differentiate between homozygous tall and heterozygous tall. So you cannot use them for calculating allele frequency directly. But what is this? This is your Q square. So out of Q square you can calculate Q. You take the root. So Q becomes 0.5. Taking the root of the percentile of the recessive phenotype gives you the allele frequency of the recessive. You have to make it sure. Don't make any error. Fine? And now when you know P plus Q is equal to 1, so obviously P becomes 1 minus Q. That means again 0.5. I told you P plus Q is equal to 1. Now if you want to verify whether you are right or not, you have P square this plus 2PQ. You have tall, you have P square plus 2PQ into the number, total number of sample that you have. So this is your 0.25 plus 2 into PQ, 0.5. You can calculate 0.5 into 0.5 into 2. So 0.25 into 2, that becomes 0.75 into n, 200, that becomes 150. That means your calculation is right. So always remember the percentile of the recessive. You take the root and that gives you the allele frequency of the recessive. And if there are two alleles and one is dominant, one is recessive, we are talking in that term, then obviously you minus it from one, you get the allele frequency of the other. There can be a different condition where both the alleles are dominant, like in the case of MN blood group, and that is very easy to calculate also. In the MN, you have genotype M, genotype MN, and genotype N. So again, this is your P square, this is Q square, this is 2PQ. But you don't have to calculate it. This is already there. What you have to do is, you just count how many M's are there, how many N's are there, and just because it is MM, that will become M into 2. And similarly, just because it is N, that will become N into 2. And in Mn, you have one M and you have one N. So it will become plus M here and plus N here. Then make it the percentile, that will give you the allele frequency. For example, let us say you have 300 M, 200 N, Mn and 200 N. So how many M's are there? You have 2 into 2, that becomes 600. How many N are there? Again, that is 400. Then you have 200 M and also 200 N. So 200 M and 200 N. That means you have 800 M and 600 N. So frequency of M will be 800 divided by 1400, and the frequency of N will be 600 divided by 1400. When both the alleles are dominant, you just count them. In the case of M, it is double MM. In the case of N, it is double NN. In the case of Mn, both are there. So split them both. Same number of M and N. And then you take the percentile, and that gives you their allele frequency. Very easy to understand. But problems arise when we talk about 3 alleles. But presently, if you can understand and if you like it, you can ask. We can continue further in the next video. Thank you.